Hey everyone, it's Zurkan. Today we have a problem when we are given an array of height and we need to find, for example, in this case, right? And we need to find the area that contains most of water. So for example, in this case, the area, so how we are calculating the area? Area, we are calculating width multiplied by height. So what's the height in this case? Height in this case is 7, right? So this one, and the width in this case also equals to 7 because it goes with the one increment, right? And 7 to 7 multiplied gives us 49. So how we are going to solve this problem? So the first brute force solution that comes into mind, that we are taking each height and we are calculating. So for each height, for example, let's take for the first height, right? We are calculating this area. So for the between first and second, we are calculating this area. And then we are calculating for the next this one and so on. And we are doing that for every other element. And then we are going to the second one, right? So we are calculating, for example, for the second one, we are calculating this one. We are calculating this one, we are calculating this one, and every time we are updating our max value, and whatever is the max, we are returning that. So but the time complexity in this case, is going to be what? It's going to be n squared, right? Because we are doing that for every element. So it's n squared. How we can do that with the one pass in with the linear time complexity? To do that, so let's actually take these 2 points, right? Let's say that we have 2 pointers. We have here left pointer and we have here right pointer. So what is the maximum? So for example, for this left one, what is the maximum area that we can make using this left, right? It's gonna be this one, right? So it's gonna be this area. So doesn't matter the next element, right? Any other element. Doesn't matter, is it more than L or less than L, right? So the maximum area that we can make using this L, the first element, is this one. So what's that mean? It means that we are going to, in every step, right, we are going to use 2 pointers, left pointer and right pointer, and at each step we are going to check that which one is lower. For example, in this case, left is lower than right, right? So it means that the maximum area that we can make using this left is this one. So we are going to calculate this area and save to our max value, right? Max value. So let's say that we have moved. So we know that this is the maximum area, which is 1 multiplied by 8, which is now, for now it's 8, right? This area is 8, we updated max, and we are moving our left pointer here. Now we are calculating this area, which one is lower? So in this case, whatever we have here, right? This one is lower than, so the height here is 7 and the height here is 8. So we are calculating this area, right? We are calculating the maximum area that we can get in this case is, doesn't matter the next element is more than our right or less than our right. So the maximum area that we can make at this point is this one, right? Is this one. So we're calculating whatever the area is here. So again, which is 7 multiplied by 7, it's 49. 49 is more than our max value, so we are updating our max value. And the time complexity in this case is linear. Okay, first thing to do, let's create the max area, which is equals to 0, and we are going to return that, return max area. And now let's create our left and right pointers. So our left pointer is equals to 0 because we are starting from the 0 index, and our right pointer, we are moving from the end of the array, so it's going to be equal to height length minus 1, last index. And now we can start to use the 2-pointer approach. So while our left is less than our right, what we are going to do, we are going to, the first thing, let's take our height. So what's our height in this case? height in this case, whatever is the minimum on the left or right, right? So we are going to take the math minimum of height left or, so we can copy paste that here, or right, right? So whatever is the minimum. So how about our width? Width is just the difference of our indexes, in this case right minus left. Okay, so now we can calculate our max area. So our max area, so we are going to check that if our current max area is more than our max area, then we are going to update that. To do that, we are going to use the max function. So we are going to compare our max area with the area with the height, with the current area, which is height multiplied to width, right? And now we are going to move our pointers. If our left pointer is less than our right pointer, then in that case, we are going to move our left pointer. Else, if it's not, then we are going to move our right pointer. So we are going to decrement our right pointer. Let's run it. Okay, great. It works as expected. And now let's calculate our time and space complexity. So what's the time complexity in this case? The time complexity is we are going over the array only once, right? It's linear, so it's O of n. How about the space complexity? It's constant because we are not using any space here. Okay, hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.